Hey everybody, now we're continuing the 8-1 Math Excel video. So on this one, based on my numbers, I know that this is going to be a 6, 8, 10 right triangle, which is like a 3, 4, 5 with a scale factor of 2. Because 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. If you don't know that, that's all right. Just do your Pythagorean theorem. 6 squared plus 8 squared equals c squared. 36 plus 64 is 100. Then you do the square root of 100, which is 10. Now, before, we said positive and negative 10, but because these are lengths of a side, it has to be positive. And so it had to be 10. Now, this is the first question that y'all don't have one angle given that's acute. All you have is a 90-degree angle. And so because of that, you might be stuck unless you pay attention. What you have to do is use your trig functions, sine, cosine, or tangent, in order to figure out the angle. So for A, if A is the reference angle, we can say this is the opposite and this is the hypotenuse. So opposite over hypotenuse means sine. So we're going to say sine A equal 8 over 10. Or you could even reduce it to 4/5 if you want. Now, we have both side lengths, and so we need to be able to get the angle. So if we have sine of A, then we do inverse sine to both sides. So we say inverse sine of 4/5. And again, make sure you're in degree mode for these. So press trig, go to inverse sine, and do 4/5. I forgot to hit Control Enter. It converted it to inverse cosine. Inverse cosine of 3/5. But that is 53.13. And since it's an angle, they wanted one decimal place, so 53.1 degrees. And then, to me, the easiest way to get the other one is just do 90 minus 53.1. 90 minus 53.1 is 36.9. And so that's your angle B. The other way to get angle B is like if you used opposite over adjacent for that, that would be sine. So sine of B would be 6 over 10, or you could say 3 over 5. And you do inverse sine of 3/5. Inverse sine 3/5, 36.869. Okay, so we're going to make that 36.9 degrees. So at any rate, if you don't have either acute angle, you have to use your inverse sine, or inverse cosine even. So let's just look at this one real quick again. If we had A as our reference, then opposite would have been 8, hypotenuse 10. Still, if A is the reference, the adjacent would have been 6. And so that 6, 6/10 would have reduced to 3/5. And so you would have gotten the same answer. Okay, now on this one, it's not a common right triangle. We just have one for this side length, so of course it's not drawn to scale because it looks longer than the side that's 6. Actually, I was looking up here. 6 is the longest because that's the hypotenuse. So let's do the Pythagorean theorem first. 1 squared plus b squared equals 6 squared. So 1 plus b squared is 36, b squared is 35. So b is the square root of 35. you know that 6 is the same as square root of 36, and so it had to be something smaller than that, whether it's square root of 35, square root of 34, 33, whatever. But in this case, it's the square root of 35. Now, when we do that as a decimal, square root of 35 is 5.916. And based on the 6, we have to round up, so we get 5.92. So that's your side length. Now for your angle, if A is your reference angle, then this is your opposite, which is 1, and your hypotenuse is 6. So you'd say opposite over hypotenuse really means sine, and sine of A is 1 over 6. So then to get A, we need to do inverse sine of that. Inverse sine of 1/6 is 9.594. We just need one decimal place, so 9.6 for your answer. The other one would have been 90 minus 9.6, which is 80.4. Now, 14, this is a word problem. It says a right triangle has a hypotenuse of 7. You might want to draw a triangle. It doesn't matter how it's oriented, but I'm going to put it like that. The hypotenuse is 7, which means the slanted side, which is the longest. And it says one angle is 43 degrees. And we need the length of each leg. Well, I will call this horizontal one X, like we usually do, and this vertical one Y. So if 43 is our reference, then the Y is the opposite, and the 7 is the hypotenuse. So if you're doing opposite over hypotenuse, that'd be sine. And sine 43 equal Y over 7. Now, when your number's in the denominator, you just multiply, so you get 7 sine 43 like we did earlier. So 7 sine 43. Again, make sure you're in degree mode, or in this case, you can use the degree symbol. Press the pi button, and right there's the degree symbol. Right under the pi. And so we get 4.773. They just want this to the 10th, and so they call that 4.8. Normally we round our side lengths to 2 decimal places, but on this word problem they had it to 1 decimal place. Now for the other one, what I would recommend is doing adjacent over hypotenuse, so that'd be cosine. So cosine 43 equal x over 7. Again, if the number's in the denominator, then you just say 7 cosine 43. Get your answer. 7 cosine 43. So I get 5.119. So we just put 5.1. Now, those are your 2 answers. I'm going to try it again like I did earlier about the Pythagorean theorem, just so I can tell you whether it's accurate or not, because I know that sometimes you might be off by like a decimal, and I need to check this. So if we say the shorter, well, between 4.8 and 5.1, 4.8 was the shorter. So make sure you don't switch those up, you know, if you did them in a different order. But let's do this as the Pythagorean theorem. 4.8 squared plus y squared equals 7 squared. So the 7 squared is really 49. The 4.8 squared is really 23.04. 23.04. And then plus. So now we need to do 49 minus that answer. That gives me 25.96. And if we do the square root, that gives me 5.095. And so based on the 9, we round up, so that's 5.1. So it looks like that would have worked as the other method, which is the Pythagorean theorem. Okay, now on this one, looks like we want to find the height of the tower, which is this, which if it's vertical, I'm going to call it y. And there's our angle, so it's opposite over adjacent. Opposite over adjacent means it's going to be tangent. And so we have tangent of this. That's a very specific angle. It's 84.729 degrees. And then they're saying that's the y over 90. So like, if the ground sank a little bit because the rain, I mean, it would have been a different angle. That's very, very specific. I mean, it's just off by like a tiny bit, then it's different. So let's do 90, tan, 84.729. 90, tan, 84.729. That gives us 975.5387. And then we round that to the 2 decimal places, so 975.54. Okay, so there's number 15. Our last one, tower casts 135-foot shadow. So the actual height of the tree, or tower, it's a tower, the height of the tower is shorter than the shadow. So that means the sun had to be over here because it's going that way. And in this problem, they're talking about the angle of elevation. Well, you can probably figure out elevation means up, depression means down. So the elevation means up, like this angle from the ground. So based on the figure, we're using opposite and adjacent, and so that's tangent. So we say tan theta equal 130 over 135. So we need to find the angle, so we do inverse tangent 130 over 135. Trig, inverse tangent, 130 divided by 135, 43.919. They want the whole degree this time, and so you'd make that 44 degrees. All right, so that's the end of 8.1. Hope that helps.